So this presentation has to do with the project I did for a semester. So this is evaluation of using a web-based 3D city model. So practically the aim of the project is to just combine 2D ALKIS data with the 3D LoD data also from ALKIS. So we created a dynamic database that incorporated these two using 3D CityDB, which is like a customized database for 3D. So we combine these two data together, we create a dynamic view, and yes, expose it to a PostgREST API. So this is the infrastructure of the whole project, basically. But the essence of this tutorial is just to put you through how the system works after we've successfully integrated the system together. So I'll do that by showing you this demo. So yeah, this link is the link to the API, just to see an instance of the API we're using. Yeah, so this is just one aspect of the. So another feature we added to the work is the visuals, is the shadow effect, which we give out to. So here, this is this area is located somewhere in Tatokai district in Stuttgart, state of Baden-Württemberg. And then we have this toggle effect, which you can use to switch on and off the shadow effects. And this shadow effects, we incorporated dates, so we can actually see the shadow effects 24 hours and then 365 days in a year. So so this is supposed to help solar panel installations and all kind of analysis developers do based on the direction of the sun. Yeah, so one other thing we included is the search effect. So what will be the link that they use of the web interface we have if it doesn't allow for analysis of the data we have in the database. So we implemented the search effect. Like I said, what we have here is 3D buildings plus information from 2D ALKIS data. So upon clicking on any 3D building here, it fetches information based on our dynamic view, combining the 2D ALKIS attributes data and then the geometry of the LoD, which is the 3D data. That is what you find here, this left hand lower part of my screen here. So to implement this search, I've copied a password ID, which I'm going to paste here and there to see how the search works. And then we used indexing so that the search is only implemented within the view on the screen. So if the password is located outside, you'll be able to see it. So this is the building highlighted here. This was also searched. You can also go further to test the different password ID. Yeah. You see this the result of this particular view. So just going forward, what next we have is to filter the building. So also to make it more usable, we implemented the building filter feature, whereby you can combine different queries to fetch your information, just to display how rich the database is, since it has combined these two databases. So we're going to compare. We are searching for building function, or the building function which are functionals, which is residential building, or the residential building with Tatokai constructed between 2001 and 2025, and then within the area of 100 to 1,000 square meters. So we're going to see those buildings highlighted. So under building function, I select even house, and then building area minimum of 100, and then maximum of 1,000, and then maybe your construction from 2000. 2001, I think too much. Okay, let's put 2001. Then to 2025, and then filter. So yeah, see some of the buildings highlighted in yellow, and then it has like over 1,000 building. Yeah, so it's see because of the size of the query, it's kind of affecting the loading effect. So yeah, this is one of the implications. And then if you look at this area, this is like 107, which is within the scope we described in the filter. But if you also check the year, it's on 2012. It's also between 2001 and 2025. So just let's just go back to I mean we also have automatic updates. Probably it will take quite some time, but okay, let's see the updates. We are going to so just to continue, this is QGIS environment. The purpose of doing this is because we want to implement an automatic update whereby we edit some feature information in QGIS, and then we directly see it's being implemented automatically, on the web browser, which is the visuals. So here we have our data, already. This is from our view, in our database, if you can see, right? So this is more like an extruded 3D or 2.5D effect. So we are going to try to edit some of the information we have here. Alright, so to do this, we are going to edit information based on the building structure table we have here. You can see. Let's put off the 3D effects, and then let's we want to want to change something here. Alright, what do we change here? Let's say we want to change say this, right? Straße. We want to change it to Wasserstraße. So give it to me instead of Straße, put it Wasser. Straße. Right? Okay, and then you just save. So now you go back to our view, and then if you remember very well, this we have that. Now you can see here the name has been changed to Wasserstraße. Right. Let's go back again, change it to Straße, and then you see it's being implemented. Straße. Save. Then go back. Click on it. You see, Straße. Right. So this is an automatic real-time display of updating information, and then see it in visualization. So this is the project we did, evaluating 2D ALKIS data and then 3D LoD1, CityGML based data, integrating them together in a dynamic PostgREST database, exposing them, and then giving them visualization and interactions. Thank you.